Welcome to this tutorial on implementing the Service Locator pattern in Unity 3D, a powerful design pattern for managing dependencies in your game development projects. The Service Locator pattern provides a centralized registry where various services, like audio or UI management, can be stored and accessed by other game objects. This approach significantly promotes modularity, testability, and ease of maintenance within your Unity projects. Let's begin by understanding the core concepts behind the Service Locator pattern. At its heart is the Service Locator itself, a central registry holding references to different services. Services are individual components providing specific functionalities, such as managing audio, user interfaces, or game states. Clients are the classes or objects that need to use these services, requesting them from the Service Locator. Services are often accessed through interfaces, which define a contract for what the service does without specifying its implementation. Registration is the process where services are added to the Service Locator, making them discoverable by clients. Conversely, retrieval is when clients request and receive a specific service instance from the locator when needed. Now, let's dive into the practical implementation steps for setting up the Service Locator pattern in Unity. First, we define a service interface, which declares the methods our service will implement. For an audio service, this might include methods like play sound and stop sound within an audio service interface. Next, we create concrete classes that implement these service interfaces. An audio service class, for instance, would implement audio service and use Unity's audio source to play sounds. The core of the pattern is the Service Locator class, which manages service registration and retrieval. This class typically uses a dictionary to store services, mapping the service type to its instance. We'll add a register method to add services and a get method to retrieve them. The register method ensures that a service is available for use, associating its interface with its concrete implementation. The get method safely retrieves a service, returning a default value or logging an error if the service isn't found. Services are registered in a central location, often a bootstrapper script, during game initialization. Inside the awake method, we register our audio service with the Service Locator. Finally, client classes, like a player controller, retrieve and use the required services. In the start method, the player controller gets the audio service instance and uses it to play a sound. Now, let's apply this pattern to specific services: audio, UI, and game manager. For the audio service, we'll define audio service with methods like play sound, stop sound, and set volume. The audio service implementation will utilize Unity's audio source components to manage sound playback. We register it in our game bootstrapper as Service Locator at register audio service new audio service . Then, any client can easily use audio service to play sound jump to trigger sound effects. Next, for the UI service, we create a UI service with methods such as show panel, hide panel, and update score. The UI service implementation will manage Unity's UI elements, like canvas and text components. Registration follows the same pattern: Service Locator.register a UI service new UI service . Clients can then update the score with UI service.update score player score . Finally, for the Game Manager service, we define iGame Manager with methods like start game, pause game, end game, and load level. The Game Manager implementation will handle game state, level loading, and other core game logic. We register it as Service Locator.register iGame Manager new Game Manager in our bootstrapper. And clients can initiate game actions using Game Manager, start game . The Service Locator pattern offers several key advantages for Unity developers. It significantly reduces dependencies between classes, leading to more modular and maintainable code. This decoupling also enhances testability, making it easier to mock or substitute services during testing. Services are managed centrally, providing a clear overview of available services and their configurations. The pattern offers flexibility, allowing new services to be added or existing ones modified without impacting dependent game objects. However, the Service Locator pattern also comes with some disadvantages. One drawback is hidden dependencies, as it can be difficult to discern a class's dependencies without inspecting its implementation. Its global access nature means everything can potentially access everything. which might lead to unintended consequences. The order of service registration matters. If a service isn't registered before it's needed, runtime errors can occur. Over-reliance on Service Locator can also lead to similar drawbacks as singletons if dependencies are over-declared. While effective, it's important to be aware of alternatives like dependency injection. Dependency injection, or DI, is often considered a more robust and flexible alternative. With DI, dependencies are provided to a class, rather than the class actively looking them up. This concludes our detailed look into implementing the Service Locator pattern in Unity 3D. By understanding and applying this pattern, you can create more organized, testable, and maintainable game code. Remember to consider its advantages and disadvantages, and explore alternatives like dependency injection for your projects. We hope this tutorial has provided you with a solid foundation for using Service Locator in your Unity development.